Your brain cannot visualize what you're about to hear. That isn't an exaggeration, it isn't a dramatic language, and it isn't a metaphor. It is a literal statement about the limits of human perception. The thing you are about to learn exists in the real universe. Astronomers have observed it. I measured it, studied its light, calculated its mass. And yet, even with all of that data, your mind does not possess the internal wiring required to truly see it. You can understand the words, you can repeat the numbers, but you cannot actually picture it. Not fully. If you've ever looked at an image of Earth floating in the blackness of space and felt small, if you've ever seen a comparison showing our planet next to the Sun and felt that quiet shock settle in, if you've ever heard that our galaxy contains hundreds of billions of stars and thought that's impossible to imagine, then what you're about to encounter goes far beyond that feeling. Because everything you think you understand about big is about to break. Let's start somewhere comfortable. Let's start with Earth. Earth feels enormous when you're standing on it. Oceans stretch beyond the horizon. Continents span thousands of miles. The planet is so vast that you can fly for hours at nearly the speed of sound and still not cross a single ocean. From our perspective, Earth feels almost endless. But then we step back. We place Earth next to the Sun, and suddenly, Earth is no longer a world. It is a dot. The Sun is so large that you could fit over 1 million Earths inside it. If Earth were the size of a grape, the Sun would be a sphere over 10 feet wide. Our planet, which holds every city, every mountain, every human who has ever lived, becomes an afterthought. That comparison alone is enough to short-circuit most people's sense of scale. But we're not done. Because the Sun, as massive as it is not special. It is one star among hundreds of billions. Now, let's widen the frame again. Our home galaxy, the Milky Way, stretches roughly 100,000 light-years from one edge to the other. That number is already dangerous to intuition, because a light-year is not a measure of time. It is a measure of distance. 1 light-year is the distance light travels in a single year, about 9.5 trillion kilometers. So, when we say the Milky Way is 100,000 light-years across, what we are really saying is this. If you could travel at the absolute maximum speed allowed by the universe, the speed of light, it would still take you 100,000 years to cross our galaxy from one side to the other. 100,000 years. That is longer than recorded human history, longer than agriculture, longer than writing, longer than cities, empires, religions, and nations combined. When modern humans first began painting on cave walls, the Sun was not even on the same side of the galaxy it is today. Our solar system orbits the galactic center at roughly 500,000 miles per hour, and even at that speed, it takes about 250 million years to complete a single lap, a single galactic year. In the entire time dinosaurs dominated Earth, our solar system didn't even finish one full orbit. That is how vast our galaxy is. And yet, this is where the illusion begins, because your brain hears 100,000 light-years and quietly files it away as very big. It doesn't protest, it doesn't panic, it just accepts it. That's because your mind is good at scaling labels, not realities. Now, let's stress that illusion. Imagine shrinking the Sun down to the size of a grain of sand. At that scale, Earth becomes smaller than a bacterium. Where would the nearest star be? Proxima Centauri, our closest stellar neighbor, would be another grain of sand sitting about 4 miles away. 4 miles. Between those 2 grains of sand is almost nothing, just emptiness. A few stray atoms, a whisper of gas. This is what space is really like. Not crowded, not packed, not busy, empty. Stars are so far apart that even entire galaxies can pass through one another without a single star colliding. And yet, somehow, despite all that emptiness, there are hundreds of billions of stars in the Milky Way alone. Already this should feel like too much. but we're still inside the comfort zone. Because deep down, your brain is still holding on to a quiet assumption. This is the scale of the universe. And for most of human history, that assumption felt reasonable. When ancient civilizations looked up at the night sky and saw the Milky Way as a hazy band of light, they believed they were seeing everything that existed. The entire cosmos stretched across the heavens. Even early astronomers thought those faint smudges in telescopes were clouds of gas inside our own galaxy. It wasn't until the 20th century, barely 100 years ago, that we discovered the truth. Those smudges were not clouds, they were galaxies, entire island universes of stars, each one containing billions or even trillions of suns. Our Milky Way is not the universe, it is one galaxy among trillions. Today, astronomers estimate that there are around 2 trillion galaxies within the observable universe. 2 trillion. That number is so large it becomes meaningless almost immediately. Your brain stops processing it as quantity and starts treating it as noise. But here's the crucial point. Not all galaxies are the same. Some are small dwarf galaxies with a few million stars. Some are spirals like our own, wide and elegant. Some are massive ellipticals that dominate entire regions of space. And then, at the extreme end of what the universe allows, there are galaxies so large that everything we've discussed so far becomes a rounding error. Galaxies so vast that if you placed them where the Milky Way sits now, they would not merely engulf our galaxy, they would consume our entire cosmic neighborhood. They would swallow neighboring galaxies whole. They would turn familiar astronomical maps into meaningless sketches. This is the point where your brain starts to resist. Because up until now, scale has been something you could at least compare. Earth to sun, sun to galaxy, galaxy to cluster. But what happens when the comparisons stop working? What happens when even galaxies become too small to serve as reference points? Let's try one more thought experiment. Imagine you are traveling at the speed of light. You leave Earth tonight. You pass the moon in a little over a second. You pass the sun in 8 minutes. You cross the orbit of Pluto in a few hours. After about 4 years, you pass the nearest star. After 100,000 years, you finally exit the Milky Way. At this point, every human civilization that ever existed is long gone. Earth itself may not even exist anymore. But you keep going. You pass other galaxies. You pass clusters. You pass structures so large they stretch across hundreds of millions of light years. And eventually, after traveling for over 1 billion years, you arrive at a place where one galaxy dominates everything around it. A single object so immense that it rewrites the meaning of the word galaxy. A structure so large that it didn't just grow alongside the universe, it reshaped its local cosmos. This galaxy exists right now. Its light is reaching us today, after traveling for more than 1 billion years through the void. When that light began its journey, complex life on Earth had not yet evolved. Dinosaurs had not appeared. The continents were arranged differently. The sky itself was unfamiliar. Every war, every discovery, every civilization, every human story unfolded while those photons were still crossing space, and they are only arriving now. In the chapters ahead, we are going to follow that light back to its source. We are going to explore how this galaxy formed, how it grew, what lies at its center, and what its existence tells us about the ultimate fate of everything. But for now, you only need to hold on to one idea. There exists a single galaxy so large that the Milky Way is not a meaningful comparison, so massive that our local group of galaxies would disappear inside it, so vast that even thinking about it strains the limits of human cognition. And that galaxy doesn't just dwarf ours, it makes the entire cosmic neighborhood feel small. For most of this story, I've deliberately avoided saying its name, not because it's secret, not because it's unknown, but because once you hear it, your brain will instinctively try to shrink it down into something manageable. Names do that. They give the illusion of control. So before we attach a label, we need to understand where this thing exists, far beyond the familiar spiral arms of the Milky Way, far beyond our local group of galaxies, far beyond the comforting idea that our cosmic neighborhood is representative of the universe. There lies a massive gathering of galaxies known as Abell 2029. Abell 2029 is a galaxy cluster, not a loose collection, not a casual association, a cluster. Hundreds of galaxies bound together by gravity, orbiting a common center of mass, embedded in an enormous halo of dark matter. The space between them is flooded with superheated gas glowing in X-rays. The gravitational forces here are so intense that entire galaxies are stretched, distorted, and slowly dismantled over billions of years. This cluster sits roughly 1 billion light-years away from Earth. That means the light reaching our telescopes today left its source before multicellular life dominated the planet. Before the first forests, before the first animals walked on land, and at the exact center of this cluster, where gravity is strongest, where motion slows, where cosmic traffic inevitably drifts, there is a single galaxy that dominates everything around it. This is the galaxy we've been circling. Its name is IC 1101. The name itself is unremarkable, almost disappointing. A catalogue label, a sterile identifier assigned long before anyone understood what it truly was. But do not let the dullness of the name fool you, because IC 1101 is not just large, it is catastrophically large. Astronomers estimate that IC 1101 spans somewhere between 4 and 6 million light-years in diameter. Pause there. 4 to 6 million. Our Milky Way, already so vast that light needs 100,000 years to cross it, would fit inside IC 1101 40 to 60 times over, side by side. If you placed IC 1101 where the Milky Way currently sits, it wouldn't merely overlap our galaxy, it would erase the map. The Andromeda Galaxy, our nearest large neighbor, drifting toward us across 2.5 million light-years of space, would lie entirely inside IC 1101's outer regions. The Triangulum Galaxy would vanish within it. The dozens of dwarf galaxies orbiting the Milky Way, entire galaxies in their own right, would become microscopic components of a much larger structure. Our entire local group, which spans roughly 10 million light-years, would feel cramped inside this single galaxy's domain. To understand just how absurd this is, let's collapse the scale. Imagine shrinking the Milky Way down to the size of a dinner plate. At that scale, Andromeda becomes another plate sitting a few meters away. Now scale IC 1101 down using the same proportions. IC 1101 would not be another plate, it would be the size of a large swimming pool. Everything you thought of as your cosmic neighborhood becomes tableware floating inside a structure designed for entirely different rules. But size is only the beginning, because IC 1101 isn't just wide, it is densely populated on a scale that borders on the absurd. Astronomers estimate that IC 1101 contains around 100 trillion stars. 100 trillion. To put that into perspective, our Milky Way contains somewhere between 200 and 400 billion stars. That means IC 1101 has roughly 250 times more stars than our home galaxy. Now let's trap your brain for a moment. Imagine you start counting stars. 1 per second, no sleep, no breaks, no pauses. At that pace, it would take you over 3 million years to count to 100 trillion. And that's assuming you never make a mistake. Never repeat a number. Never lose track. By the time you finished, counting modern humans would have existed for only a fraction of that time. Entire species would rise and vanish while you were still counting. This is not a galaxy you comprehend. It is a galaxy you confront. And what makes this even more unsettling is that IC 1101 doesn't float alone. It sits at the gravitational heart of Abell 2029 like a cosmic emperor, dominating the motion of everything around it. Smaller galaxies orbit it, drift toward it, slowly fall inward. Some are already being torn apart, their stars stretched into long, ghostly streams as they are absorbed. Which brings us to a strange historical twist, because IC 1101 has been visible to human astronomers for over 2 centuries. We just didn't know what we were looking at. In 1790, a German-born British astronomer named William Herschel was systematically surveying the night sky. Herschel was already famous. He had discovered the planet Uranus. He had catalogued thousands of nebulae and star clusters. On June 19th of that year, he pointed his telescope toward a faint, fuzzy patch of light in the constellation Virgo. He logged it, measured its position, and moved on. At the time, Herschel had no reason to think this object was special. Telescopes of the era could not resolve its structure. There was no way to measure its distance, no concept of galaxy clusters, no understanding that these faint smudges were entire universes of stars. So IC 1101 entered the records as just another nebula, and for more than a century it remained exactly that, a quiet entry in a catalogue. It wasn't until the 20th century, when astronomers developed better telescopes and learned how to measure cosmic distances, that the truth began to emerge. Spectroscopy revealed its extreme distance. Photographic plates showed that it extended far beyond what early observers had assumed. Later, space-based telescopes confirmed that IC 1101 was not just another galaxy, it was one of the largest stellar structures ever discovered. The light we observe from IC 1101 today began its journey over 1 billion years ago. When that light left its home galaxy, Earth was a profoundly different place. Complex animals were only beginning to diversify. The atmosphere held different chemistry. The continents were arranged differently. Every human achievement, from the first stone tools to space telescopes themselves, occurred while those photons were in transit. IC 1101 is not just far away. It is ancient in a way that humbles imagination. And yet, despite its size, despite its star count, despite its gravitational dominance, IC 1101 presents astronomers with a deeper mystery. Because size alone doesn't explain how something like this can exist. Galaxies do not form fully grown. They are not born enormous. They grow, they collide, they consume, they evolve. So, the real question isn't how big IC 1101 is. The real question is, what had to happen to create something this extreme? And the answer leads us into a story of cosmic violence, of galaxies tearing each other apart, of stars being flung into intergalactic space, and of a process so relentless that it transforms the universe one collision at a time. But size alone doesn't explain how something like this can exist at all. Galaxies are not peaceful. From a distance, they look serene, vast pinwheels of light drifting through a silent universe. But that calm is an illusion created by time. What we see in photographs is not a moment. It is the frozen blur of events unfolding over hundreds of millions of years. On those timescales, galaxies are predators. They hunt, they collide, they tear one another apart. And the galaxy we've been following, IC 1101, is not merely a participant in this process. It is its most extreme outcome. To understand how something so large can exist, we need to abandon the idea that galaxies grow gently. There is no slow accumulation, no peaceful expansion. Galaxies grow by destroying other galaxies. This is not speculation. It is one of the foundational principles of modern cosmology, known as hierarchical structure formation. The universe builds large things by smashing smaller things together. In the early universe, only small galaxies existed, dwarfs, formed from collapsing clouds of primordial gas. Over billions of years, gravity pulled these small galaxies into larger ones. Those larger galaxies then merged again and again and again. Growth through consumption, survival through dominance. Nowhere is this process more violent than inside a galaxy cluster. Clusters like Able 2029 are gravitational traps. Hundreds of galaxies move through them at millions of miles per hour, pulled into elongated orbits by vast halos of dark matter. Close encounters are inevitable, And when galaxies pass too close to one another, gravity does not negotiate, it tears. Imagine two galaxies approaching. At first, nothing seems wrong. Stars continue their orbits, unaware of the intruder. But as the distance closes, the gravitational pull from the approaching galaxy begins to distort everything. Stars are tugged out of their paths. Gas clouds stretch and compress. The delicate balance holding spiral arms together begins to unravel. This is called tidal forcing, and it is ruthless. Long streams of stars are pulled from the edges of galaxies like glowing wounds, forming ghostly tails that stretch for hundreds of thousands of light years into space. These are not decorative features. They are evidence of ongoing destruction. If the two galaxies are similar in size, the encounter becomes a prolonged struggle. They pass through one another, separate, slow down, and fall back together again. Each pass strips away more structure, more order. But when one galaxy is much larger than the other, the outcome is not a struggle. It is a feeding. The smaller galaxy is torn apart. Its stars are stripped away and absorbed into the larger galaxy's halo. Its gas is heated to extreme temperatures, either forming stars in violent bursts or being blown out into intergalactic space. The smaller galaxy does not survive. This process is known, without exaggeration, as galactic cannibalism, and IC 1101 is one of the most prolific cannibals ever discovered. Astronomers estimate that over its lifetime, IC 1101 has undergone at least 70 major mergers. 70. Each one involving another substantial galaxy. That number does not include the countless dwarf galaxies it has consumed, systems so small that they barely register individually, but together contribute enormous mass. Each merger added stars. Each merger added dark matter. Each merger erased structure. Over billions of years, IC 1101 did not simply grow, it devoured its environment. The evidence for this history is written into its very shape. Look at the Milky Way and you see spiral arms, organized rotating structures rich with gas and dust. These arms are stellar nurseries where new stars are still being born. IC 1101 looks nothing like this. It is an elliptical galaxy, a vast, smooth, featureless cloud of stars with no arms, no disk, no obvious rotation. Elliptical galaxies are not born this way. They are made. When spiral galaxies merge, their graceful structure cannot survive the chaos. Stars are thrown into random orbits. Gas clouds collide and heat up. The ordered rotation that once defined the disk is destroyed. After enough mergers, all that remains is a swollen, amorphous mass of stars orbiting in every direction at once. This is what IC 1101 has become, a graveyard of former galaxies. Its stars are no longer arranged in elegant patterns. They are mixed. Stars born in entirely different galaxies, billions of years apart, now sharing the same space. Chemical signatures in these stars reveal different origins, different histories, stitched together by violence. And there is a cruel irony here. Despite containing 100 trillion stars, IC 1101 is not a place of creation. It is a place of exhaustion. Galaxies need cold gas to form new stars. Hydrogen must be able to cool, collapse, and ignite nuclear fusion. But every time IC 1101 consumed another galaxy, it stripped that galaxy of its gas. Some of that gas was compressed into stars in brief, intense bursts, violent flashes of creation triggered by destruction. But much of it was heated to extreme temperatures during mergers, becoming too hot to collapse again. Over time, IC 1101 lost its ability to give birth. Today, it is what astronomers call a red and dead galaxy. Its stars are old, mostly red giants and long-lived, low-mass stars nearing the end of their lives. Very few new stars are forming. The raw material is gone. The galaxy grew so large that it consumed the very fuel needed to sustain itself. It conquered everything around it, and in doing so, sealed its own fate. IC 1101 is massive, dominant and ancient, but it is also dying. And this is where the story becomes even darker, because the cannibalism didn't stop with stars. Every galaxy IC 1101 consumed carried something else with it. At the center of almost every large galaxy lies a supermassive black hole. When galaxies merge, those black holes eventually meet. They spiral toward one another through a sea of stars, dragging space and time into violent distortions. When they finally collide, they merge into something larger, releasing gravitational waves powerful enough to shake the universe itself. IC 1101 has experienced this process dozens of times. Each merger added mass to something lurking at its core. Each act of galactic consumption fed a growing singularity. The structure of IC 1101 reflects this history. Its central region is unusually large and faint, evidence that stars were flung outward by repeated black hole mergers, leaving behind a hollowed-out core. Hundreds of billions of stars may have been ejected from the center alone. This galaxy has been reshaped from the inside out, a smooth, swollen shell of stars surrounding a history of catastrophic mergers. And yet, all of this, the torn galaxies, the stripped stars, the dying stellar population, is only the surface of the horror. Because at the heart of this vast, exhausted giant lies something far more extreme than the galaxy itself. Something so massive that it warps time. Something that shaped IC 1101's fate as much as IC 1101 shaped the cluster around it. A presence that has fed on the remains of dozens of galaxies and now waits, silent and immense, at the center of the darkness. And at the heart of this dying giant lies something even more extreme. At the center of IC 1101, there is almost nothing to see. No blinding light, no glowing spiral, no visible structure that announces its presence, and yet this invisible thing is the most powerful object in the entire galaxy. It outweighs stars. It outweighs clusters of stars. It outweighs entire galaxies that once existed independently. Hidden at the heart of this vast, dying giant is one of the largest known supermassive black holes in the universe. Astronomers estimate its mass to be somewhere between 40 and 100 billion times the mass of our Sun. That number is difficult to process, so let's dismantle it carefully. At the center of the Milky Way lies a black hole called Sagittarius AI. It contains about 4 million solar masses. Already that black hole is powerful enough to dominate the orbits of stars across tens of thousands of light years. The black hole at the center of IC 1101 may be 10,000 times more massive. This is not just a difference in degree. It is a difference in category. Black holes grow heavier, not larger in the way normal objects do. As their mass increases, the region from which nothing can escape, the event horizon, expands outward. For a black hole of this size, the event horizon would stretch far beyond the orbit of Pluto. If you placed this black hole where our Sun sits now, the entire solar system would be gone. Mercury, Earth, Jupiter, Neptune, all swallowed before anything could react. And this is the most unsettling part. Outside the event horizon, there is no visible warning. If you were drifting toward it, you would not see a wall. You would not feel a push. You would not hear anything. You would simply cross a boundary in space where escape becomes impossible. From that moment on, every path leads inward. To understand what that means, we need to talk about how black holes distort time itself. As you approach a black hole, gravity grows stronger. According to Einstein's theory of general relativity, strong gravity slows time. The closer you get, the slower time passes for you compared to the rest of the universe. If someone were watching you fall toward the black hole from a safe distance, they would see you slow down. Your movements would stretch. Your final moments would seem to last forever. You would never appear to cross the event horizon, but from your perspective, something very different would happen. Time for you would continue normally. You would fall. You would cross the horizon. And once you did, there would be no version of the universe where you come back out. Inside the event horizon, space and time exchange roles. Moving forward in time becomes as unavoidable as moving forward through space is for us right now. Escape is not difficult. It is meaningless. As you fall deeper, tidal forces begin to tear you apart in a process physicists grimly call spaghettification. Gravity pulls more strongly on the part of your body closer to the black hole than the part farther away. The difference stretches you, atom by atom, into a long, thin strand. Your molecules unravel. Your atoms separate. Your very structure becomes geometry. All of this happens without drama. No explosion, no sound, no final moment, just inevitability. And yet, despite possessing this unimaginable power, the black hole at IC 1101's center is strangely quiet. Right now, it is not actively devouring vast amounts of matter. There is no blazing accretion disk, no brilliant quasar visible across the universe. The monster is dormant, but dormancy does not mean harmlessness. Astronomers have found clear evidence that this black hole was once violently active. Radio telescopes have detected enormous jets of particles launched from the galaxy's core, traveling at near light speed. X-ray observations reveal vast cavities carved into the surrounding hot gas, bubbles so large they stretch for millions of light years. These cavities were inflated by energy released near the black hole, likely during periods when it was actively feeding. The amount of energy required to create them is staggering, equivalent to the combined output of billions of stars over millions of years. This is the feedback loop that shapes galaxies. When gas falls toward a supermassive black hole, it heats up, accelerates, and releases enormous energy. That energy can push surrounding gas outward, preventing it from cooling and collapsing into new stars. In other words, the black hole does not just consume, it regulates. In IC 1101's case, this feedback likely helped shut down star formation entirely. The galaxy grew massive, merged again and again, and fed its central black hole, until the black hole returned the favor by heating and expelling the remaining gas. The galaxy and the monster at its center evolved together, each shaping the other, each limiting the other. IC 1101 became enormous but sterile. The black hole became immense but quiet. They reached a kind of cosmic equilibrium, a balance achieved through destruction, and this balance cannot last forever. Black holes grow by eating matter, but even black holes are not eternal. They do not last forever. According to our best understanding of physics, black holes slowly lose mass through a process known as Hawking radiation. Over unimaginably long periods of time, they leak energy and shrink. For stellar mass black holes, this process takes longer than the current age of the universe by many orders of magnitude. For a black hole as massive as the one in IC 1101, the timescale is so vast it defies notation, something like 10 to the power of 100 years, a Google years, a number with more zeros than there are atoms in the observable universe. And yet, even that is finite. One day, trillions upon trillions of years from now, this black hole will evaporate. It will disappear. The most powerful object ever assembled by gravity will fade into nothing, releasing its final whisper of energy into an empty universe. This realization reframes everything we've discussed. IC 1101 feels eternal because we are fleeting. Its black hole feels infinite because our lifespans are microscopic. But the universe does not care about our sense of permanence. Everything changes. Everything ends. And this brings us to a strange, humbling truth. IC 1101 is not the final form of cosmic structure. It is a temporary peak, a moment when matter has assembled itself into one of the largest, most powerful configurations the universe allows. And even giants like this are temporary. For most of this story, IC 1101 has felt unstoppable. A galaxy so large it consumed others without effort. A structure so massive it reshaped its entire region of the universe. A giant that seemed to stand above time itself. But the universe does not grant immortality. Not to stars, not to galaxies, not even to the most powerful black holes ever formed. To understand the final fate of IC 1101, we have to step far beyond human history, beyond civilizations, beyond planets, beyond even the era of stars, and look at where the universe itself is heading. Right now, space is expanding. This has been known for nearly a century. Galaxies are moving away from one another as the fabric of space stretches. But in the late 1990s, astronomers discovered something unsettling. The expansion is not slowing down, it is accelerating. Something still not fully understood is pushing the universe apart faster and faster. Scientists call it dark energy, and it makes up nearly 70% of the total energy content of the cosmos. Dark energy acts like a quiet pressure embedded in space itself. The more space expands, the more of this energy exists, and the stronger its effect becomes. Over time, gravity loses. On the larger scales, dark energy wins. As billions of years pass, galaxy clusters begin to drift apart. Light from distant structures stretches and reddens as it travels. Eventually, those galaxies recede so quickly that their light can no longer reach us at all. They vanish beyond a cosmic horizon. From the perspective of any future observer, the universe begins to empty. For IC 1101, this future brings isolation. The Abell 2029 cluster will remain bound together for a long time. Gravity is still strong enough to hold its galaxies in orbit. Within the cluster, mergers will continue. Smaller galaxies will fall inward. The giant at the center may grow slightly larger still. But beyond the cluster, the universe will slowly disappear. Other clusters will fade one by one. Their galaxies will stretch into invisibility. The sky will grow darker, emptier, quieter. Eventually, IC 1101 and its cluster companions will be alone. Not metaphorically, literally. From their vantage point, there will be no other galaxies visible anywhere in the sky. The universe will appear to contain only a single massive structure surrounded by endless blackness. Cosmic loneliness on a scale that defies imagination. And yet, even in isolation, time continues to move forward. Stars burn, and stars die. Inside IC 1101, star formation has already slowed to a near halt. The cold gas needed to create new stars has been used up, heated, or expelled. No new generations are waiting to be born. What remains is an aging population of stars, quietly running out the clock. The largest stars, massive blue giants, died long ago. They lived fast, burned hot, and exploded as supernovae within a few million years of their birth. Stars like our Sun live longer, roughly 10 billion years. They swell into red giants, shed their outer layers, and leave behind glowing white cores called white dwarfs. But the most important stars in the far future are the smallest ones, red dwarfs, tiny dim stars with a fraction of the Sun's mass. They burn their fuel so slowly that they can shine for trillions of years. Some red dwarfs born early in the universe have not changed appreciably since before Earth existed. In IC 1101, red dwarfs will be the last sources of starlight. For trillions of years after larger stars have died, these faint embers will continue to glow, scattered across the vast body of the galaxy. The universe will be old beyond comprehension, but not yet dark. Eventually, even red dwarfs exhaust their hydrogen. When that happens, the era of star formation ends forever. No gas remains dense enough to collapse. No nuclear fires can ignite again. The universe enters what physicists call the degenerate era, a time dominated by stellar corpses. White dwarfs drift through space, slowly cooling. Neutron stars spin down, losing energy. Black holes persist as silent anchors of gravity. In IC 1101, the galaxy that once held 100 trillion stars becomes a vast collection of remnants. And then, over even longer spans of time, those remnants fade too. White dwarfs cool until they emit no light at all, becoming hypothetical objects known as black dwarfs, cold, dark spheres of degenerate matter. This process takes an almost inconceivable amount of time, on the order of 1,000,000 billion years. By then, the universe is unimaginably old. The night sky, if anyone could still see it, would be almost completely black, and still, the black hole at the center of IC 1101 remains. For a long time, it is the final monument to everything that once existed there. But even black holes are not eternal. Through quantum effects near the event horizon, black holes slowly lose mass by emitting radiation, Hawking radiation. For supermassive black holes, this process is incredibly slow. The larger the black hole, the longer it takes. For the one at the heart of IC 1101, the timescale is staggering. Something like 10 to 100 nanometer years, a Google years. Time spans so vast that writing them down strains language itself. But even that is not infinity. Eventually, after all stars have gone dark, after all galaxies have faded beyond reach, after the universe has stretched into near emptiness, the black hole will evaporate, it will shrink, and one day, it will vanish entirely, leaving behind nothing but faint radiation dispersing into an ever-expanding void. When that happens, IC 1101 will no longer exist. No stars, no black hole, no galaxy, just particles drifting farther and farther apart in a universe approaching complete stillness. This future sounds bleak when measured against human emotions, but that is only because we are looking at it from the wrong angle. The universe is not a tragedy, it is a process, and we exist at an extraordinary moment within it. Right now, we live during what cosmologists call the stellar era, the brief window of cosmic history when stars shine, galaxies glow, and complexity is possible. This era will not last forever. In fact, compared to the deep future of the universe, it is astonishingly short. And yet, within this fleeting moment, something remarkable has happened. The universe has become aware of itself. On a small, rocky planet orbiting an ordinary star within an average spiral galaxy, matter organized itself into minds capable of asking questions. Minds capable of looking out into the darkness and discovering IC 1101, a galaxy more than 1 billion light-years away, a structure containing 100 trillion stars, a giant so vast it breaks intuition. And we know it exists. We have measured its size, traced its history, understood its fate. That is not nothing. That is extraordinary. To understand this, imagine one final image. Imagine yourself floating somewhere inside IC 1101, not near the center, not near the edge, just drifting among its stars. In every direction you look, there are suns, trillions of them, stretching outward beyond sight. Their light overlaps, soft and ancient, forming a glow that has no clear boundary. You cannot see the edge of the galaxy. It fades gradually into darkness, indistinguishable from intergalactic space. You cannot see the center either. It lies millions of light years away, hidden behind layers upon layers of stars. You are suspended inside a structure so vast that crossing it would take longer than human civilization has existed, multiplied 1,000 times over. And yet, from a small planet far away, beings who live for less than a cosmic heartbeat figured this out. They learned that this place exists. They learned how it formed. They learned how it will die. In a universe that will one day go dark, that knowledge is a kind of light. IC 1101 will fade. The stars will go out. The black hole will evaporate. But for a brief moment in cosmic history, the universe assembled itself into something capable of wonder. And that, more than size, more than power, more than permanence, is the true miracle. Not fear, not despair, just awe, silence, and the quiet realization that the universe has looked at itself and understood what it saw.